Alright, here's another video about a question from section 3.4, and I'm starting here with question number 6, and it says, assume that a procedure yields a binomial distribution with a trial repeated n equals 5 times. Use some form of technology to find the probability distribution given the probability P of success here, 0.506 of success on a single trial. And so we have a chart here. We're looking for the probability of success for 0, 1, 2, 3, 4, 5, 6. Now this is question 6, and question 7 is similar. I like question 7 just a little bit better because it has a context here. So it says, assume the proportion of voters who prefer candidate A is P equals 851. Organization D conducts a poll of n equals 5 voters. Let X represent the number of voters polled who prefer candidate A. Use some form of appropriate technology to find the cumulative probability distribution. So I wanted to kind of show how I might tackle this one using technology and kind of relate it back to the previous one. So I'm going to make a quick little snip here of the question, and I'm going to do question 6 with this data, and then also question 7 with this data. So I'm going to pop over to Excel here, paste this in, and then I'm going to see if I can't steal this table here. This may or may not work because it has answers in there. We'll see what happens when I try to paste it here. Again, I'll try to paste special, try to demo that, see how it shakes out, and we get something like this. Okay, so this works. So first of all, I'm going to say question 6 here, whoops, and then let me paste special again, give myself a little bit of room for question 7. So I believe there's like a slight difference here, and it's like x less than or equal to k, and then I guess this one would be x equals k here, and so I've got k. Okay, so on the first one, when I'm talking about question 6, it was the probability of exactly this many happening. And the nice thing about this is we have the probabilities here, 0 all the way up here. Now the important data from this question here, the probability of success is 0.851, and the number of trials is 5. So in both of these cases, we can have 0 out of 5, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, and 5 out of 5, so on and so forth. So if I want to create the first one, this is a binomial distribution. And if I want to create it easy style, I can click on the 0 because that's going to be the number of successes. I have 5 trials, and I'm going to just type that in. If I click up here, it can get kind of wild and pull them down. The probability of success, 0.851. I'm going to type that in 2 also. And then for exactly that outcome, I just want to use false here as we go. Oh, this is perfect. Okay, so a couple of things happened here. Some of these values are really, really small. This thing right here, 7.34398e to the negative 0.05, the science teachers don't like us saying this, but I'm going to say this anyway. This is like, well, I'll say it's like scientific notation. It's not scientific notation, but essentially it means 7.34398 times, or times here, 10 raised to the negative 0.5 or negative 5th power. And I want you to know that, because what that means, sometimes I get people to enter these as their probabilities, and they enter like 7.344 or something. What this really means is I've got 0.0000, I've got 4 zeros, and then the next value is a 7.34398, and Excel just puts that into, air quotes here, scientific notation, changes it like this. But you want to know that this is what it means here. So if I was rounding to 4 decimal places, this would be 0.000, maybe 1. Anyway, so that's the probability of success. Now how it switches here for problem 7 is it's cumulative. So this is a cumulative probability distribution. And what that means, the first one really is this value. So binomial distribution. I've got 0 successes out of 5, and I've got 0.851. I think I missed the decimal. 851. And then this is true. So I use true if I want a cumulative output. I should put this here. Going back to showing my work, kind of showing the difference here. These guys, and essentially this one, it comes down and it just follows B13, then B14, and so on and so forth. And so notice here, these two values have the exact same value. Or these two answers are the exact same value. Now, what this means here for the next one, and I can take this and I can kind of copy it down and it will update it as it goes. So notice here, 0 all the way to 1 with a cumulative probability distribution, because the probability of less than or equal to 5 successes out of 5, it should be all of them. It should add up to 1. Now, I could have also taken this value and added to it this one over here to find this. Now we have a little bit of rounding. If I want to make it better, I can make it longer here. And if I drag this down, it'll complete the same way, getting the same values. So the binomial distribution with the true just gives us all these outputs all together here for us. We don't have to do all that little bit of work along the way. So true again, if I use a true at the end, this is going to be up to and including this value. If I use false, it's going to be exactly that value. So one's a cumulative distribution function and one's just a probability distribution function, so you have that. Anyway, a couple of things that you may or may not need to know. Now this has in here, you can use Excel or stat disk. You need to use Excel or your calculator, TI-84. But I think this is a great tool for it and it shows the work well, so this is what we're doing for this class. Again, thank you. I hope that's helpful. A couple more questions out of section 3.4. And again, wish you continued success in the class. And you come with the questions and let me know if you have them so I can answer them for you. Thanks.